announcement. I'll pause it for that there. But I want to get started on this so that we have time. It took about 42 minutes to get through this first hour. Now, 1 through 5 is describing the transformations. 4 and 5 will not, there's one part of 4 and 5 that will not show up on the test. And that's having a negative inside the parentheses. The negative inside the parentheses is a reflection across the y-axis. And the reason I am not including that on the test is because, well, if we talk about the reflection across the x and y-axis, that's fine because I have a negative outside and a negative inside. It's a reflection because there's a negative in both of those spots, yes? But because I listed this first, this equation really looks like this here. I have to pull that negative out of the two terms inside the parentheses. It's not coming completely out, but I have to factor it out there because it changes how it moves. So really this here is right 4 and down 1 with a vertical shrink of 0.7. Because of that reflection on the across the y-axis, it changes how it moves. Because now if I said it went left 4, because it is plus 4, right? If I said left 4, down 1, then reflected, it would be correct. But because I say reflection across the y-axis first, I have to change how it moves. I'm not including this here. The reflection across the y-axis is not going to be on the test, so we don't have to worry about that factoring out the negative. Does that make sense? If there's a reflection, it's going to be across the x, okay? Because if the negative is outside the parentheses, it's not in a set of parentheses. It's not across the x, it's across the y. If it's inside parentheses, it's across the y. And as we see this here, it messes with it. Horizontal stretch and shrink messes with the function, and so does reflections across the y. They change how it looks. So we're not worried about this here. So 4 and 5, don't even worry about writing, just because the rest of them don't have that. They don't have it. So let's look at 1. Let's look at number 1. Here, we have 1/2 out front, yes? And that's normally where we talk about a vertical stretch or a vertical shrink. Because it's less than 1, it would be a vertical, what? Shrink of 1/2. And then right 1 and up 3. And that's it. Now, if the 1/2 had been negative, it would have been a reflection across the x. Okay?
So it's not if it says like -1, you just flip it.
Yep.
So if it's
It would be left. If it's +1, it goes to the left. If it's -1, it goes to the right. And it's really going back to the, I'll call it vertex form because it is. Y equals a times x minus h squared plus k, the x minus h. It's kind of the reasoning behind that. And it's almost if we want to move it 1 to, just the basic parent function is at 0, 0, the bottom, the vertex. If I want to make that at 1, 0, I want to make it so the value of x when I plug 1 in will still give me 0 for y. I can't add 1, I've got to subtract it so it goes back to 0. That's kind of why that works that way. It's not hugely important that we fully understand it or grasp it because it's not crucial. But that's about it here. Do we have questions?
what was it whenever, like, if it's above a certain number, it's going to be...
So this one here, the 4, tells me it's a vertical stretch. If it's between 0 and 1, it's a shrink. If it's a greater than 1, it's a stretch. And if it's negative, it's just a reflection across the x. So if the number outside the parentheses there's not parentheses around it, and it's negative, it's a reflection across the x. Questions on these here? We good with these here? Okay. Hold on. Okay, now it's catching up. 11 through 15. I'm going to include vertex on this. This is our y equals 1 over 4p times x minus h squared plus k. Vertex is h comma k. Focus is h comma k plus p. Is that what y'all have written down? Yes. And y equals, okay, minus p, and our axis of symmetry is x is equal to h. The other one we had was x is equal to 1 over 4p times y minus k squared plus h. Vertex is 0, 0, not 0, 0, it's h comma k. I'm getting ahead of myself. Focus is h plus p comma k. H minus p, and the axis of symmetry is y is equal to k. Now, no matter what this is, because when we did these on the homework assignment and we did these in class, we had a type where the vertex was 0, 0, and we dealt with these certain equations, yes? And then we dealt with the other two types, the other 2 days we spent on it. We talked about these here, yes? These here work even when the vertex is 0, 0. These here work even when the vertex is 0, 0. And I'm going to start teaching it this way first instead of the way we did it this year, because it seems to work better. And we can even use these here, even on the test. So here, do I have an h and k for this problem? No, there's not something added to it inside parentheses. There's nothing outside. So h is 0. K is 0. There's nothing there, right? H is 0. K is 0. Because h is inside, or k would be inside. But there's nothing added inside here. There's no parentheses. So that value for here with h is 0. Nothing added at the end. K is 0. So that means the vertex is what? 0, 0. It's 0, 0. Focus. Directrix and axis of symmetry. Now the axis of symmetry is going to be what? X equals h. Well, that's just 0. H is 0, yes? Directrix is going to be y equals k minus p. But we don't have k. Well, we know k is 0, yes? But do we know what the value of p is right now? Not directly. And focus is h comma k plus p, so 0 comma k plus p. So we have almost everything, yes? Even if we get stuck, even if you get stuck on the day of the test and you can't figure out what p is or how to get there, we can find h and k pretty easily, yes? So looking at this here, I'm missing 2 numbers. I'm doing pretty well. For overall scheme, you're doing pretty well. Now, to find the value of p, well, it shows up right here, because the negative 1/12 is in the spot where 1 over 4p should be. So I set it equal to it. I set negative 1/12 equals 1 over 4p. Now to get it by itself, we're going to multiply both sides by 4p. Does those cancel? 1. Negative 4p over 12 is what we get after we multiply. Well, 4 over 12 will reduce, yes? To negative p over 3. Well, what do I need to do to get p by itself? I'm going to multiply both sides by negative 3. Because I will get p by itself, and it's positive, and it equals -3. Questions on how we found the value of p? Questions on how we found this value of p? We're good with this here, finding the value of p? Multiplied both sides by 4p.
Once you got to simplified 4p,
Mm-hmm.
4 it's over negative 3.
Yes.
So you multiply by negative 3.
Yes. So we multiplied both sides by 4p and got -4p over 12 equals 1. Simplified it down, multiplied both sides by -3, and we got the value of p. Now the focus is h plus p. Well, the value of h is what? We have 0 plus -3, which is -3. We plugged it in. The directrix is k minus -3. Well, negative and negative will make a. So it's just 3. If you need to write those out, write those out. Because here with 0, it worked out nicely. But again, the negative and negative, it would be easier just to write them down sometimes. Just so we keep them straight, yes? But that's it. That's all we need to do for this here. That's all we need to do for this here. Any questions on number 11? Any questions on number 11? We good with 11? So k minus p, -3. The negative and negative make a, yep. So writing it down is not bad. Writing it down is not a bad way to do this, okay? We're going to look at this here. There's another one like it on the review, because 13 is kind of like it. But what we need is the value of the variable without an exponent by itself. We need the variable without an exponent by itself. So on 13, to get that, we would have to divide both sides by 48. Here, I have x and y on the same side, yes? So what I need to do, here we just need to add y. So on 13, you would divide both sides by 48 to get y by itself, because I think it's y. But here, we're going to add y to both sides to get this here. Well, what's h and k? They're still both 0, aren't they? Because there's nothing in the h where h would be or k. Because even if we flipped it, there's nothing being added inside the parentheses, and there's nothing being added or subtracted from x squared. So h and k are both 0 here. So the vertex, 0, 0. Focus is 0, comma, k plus p. Directrix would be y equals k minus p. And axis of symmetry is x is equal to h. Yes? So I'm copying those really, if I were doing the test right now, I would be mainly copying those down straight from the guide, like a set of equations, h and k. I know those are both 0. I fill it in. Focus, well, h is 0, so 0, comma. We don't know p is, so I'll leave it blank. I don't know p for the directrix, so I leave it blank. X equals h is 0. I fill it in. I need to find the value of p and the two numbers that are missing, and I'm done. So, what matches up with 1 over 4p? That would equal what? Just 8. Because the 1 over 4p goes in front of whatever the x squared is, or the set of parentheses squared, is where the 1 over 4p is. It's where it matches up. So I know that number, that value of p, when plugged in to 1 over 4p, will give me 8. It'll give me 8. So the first thing we need to do is we need to multiply both sides by 4p, because 4p and 4p will cancel. Leave me 1 is equal to 32p. And then what do? We divide both sides by 32. So p is equal to 1 over. Any questions on how we found this value of p? Any questions on how we found this value of p here? Are we good with this here? Any questions on any of this here? So now we need to go and plug it back in. So, well, for the focus, we're going to have 0 plus 1 over 32, which is just 1 over 32, yes? And 0 minus 1 over 32 is going to be negative 1 over 32. For this one here, we didn't have any issues with the double negatives or minus a negative. We ended up getting 1 over 32 and negative 1 over 32. 1/32. Any questions on this here? We good with all this here so far? Okay. Now, most of the rest of these here are going to be the same thing. We do the exact same process for these. 16, not on the test. 17, not on the test. All right, let's look at this one here. Number 18. The vertex tells me that the values of h and k are 0, 0, yes? Now the directrix tells me this here x equals, so x equals h minus p, yes? So this is saying that negative 9 is equal to h minus p. Well, what did we say the value of h was? 0, yes? So 0 minus p. Let's just, negative 9 is equal to negative p, yes? Are we good so far? So we're going to divide both sides by negative 1. We can multiply both sides by negative 1. It really doesn't matter. It's just going to say that p is equal to 9. P is equal to 9. Plug it in to find the equation. So we said p was 9, so we get x equals 1 over 4 times 9 times y minus 0 squared plus 0. Actually, that should be k, and that should be h. Well, 4 times 9 is 36. Well, y minus 0 is just the same as saying what? Y by itself, yes? So really, this simplifies down to just this here. Because the plus 0 is not necessary, adding 0 doesn't change anything, and subtracting 0 from the inside doesn't change anything. So we can pretty much drop all that out, and it just leaves us with y squared. Any questions on this here so far? Any questions on anything we've done so far? We good with this here? Okay. I want to look at this one here. So what we did, I'm going to do one of these here, and what we did on the first one, where we found the vertex, axis of symmetry, directrix, and the focus, but we found a lot of it at 0. It's similar to what we're going to do here, except the focus, except the vertex isn't 0, 0. So what's the value of h for this one here? The value of k is, when it's x equals, h and k have flipped. H is not inside the parentheses anymore. It's outside. So we have to pay attention to that. Here is h. Here is k. Because for this equation, k is inside the parentheses, h is outside. So we have to pay attention to what equation is given. And 1 over 4p is equal to what? 4. 1 over 4p is equal to 4. So what do we need to do to both sides? We need to both sides by 4p, because these will cancel out, leaving us 1 is equal to 16p. Then what do we need to do? Divide both sides by 16, and I get p is equal to 1/16. Now the focus, or the vertex, is h comma k. Okay, so the vertex is h comma k. Well, the value of h was what? -1, and the value of k is -5. So we plug in h and k. The focus for this here would be h plus p comma k. Well, we know k, it's -5. H plus p, so h is -1 plus 1/16, because h plus p. And you can do this in a calculator. If we do it in a calculator, we should get -15/16 for the focus. Now the directrix would be x is equal to, and this time we have h minus p. And if we do this in a calculator, we should get -17 over 16. And the last one is y is equal to k for the axis of symmetry. So mainly what we did for all of these here was we went in and filled in for the values of h and k and p, once we found the value of p, and simplified it down. So any questions on this here? Any questions on anything we've done so far? Because here, this is our formula, x equals, yes? Yeah. K is inside, h is outside. Now if we look at y equals, h is inside, k is outside. Oh, so which one it is? Because I've seen it happen time and time and time again, where we get used to h and k being in this way here. So even when you hit this one here, you still put the value inside as h and the value outside as k. Y'all see that distinction between these two equations? So it's paying attention to which one it is, and if you are paying attention to which one it is and which equations and numbers you're looking at, you'll be fine. But you just need to be paying attention to what the equation is, if it's x equals or if it's y equals. If you do that, you won't have a problem with either one of these, with figuring out what we're setting equal. Any other questions on 20 through 23? Are we good with 20 through 23? Yes. 23. 24 through 27. Any one of those in particular? Because if not, I'm just going to work on 24. Yes? Okay. Now the vertex, we know it's h comma k. Vertex is always going to be h comma k. Now the focus I notice that the x value changed, yes? This is still k. Well, because the x value changed, when I look over here, the one I notice that changes from one to the other is the x for this one here. For the other equation, it's the y value that changes. So since the x value changes, it means I'm using x equals 1 over 4p times y minus k squared plus h. I'm using this formula here because the x value of the focus and the x value of the vertex change. They're two different numbers. So we're using this equation. And it also tells me that 14 is h plus p. It's telling me that h plus p is equal to 14 because that's what it is in the focus. The focus's x value is h plus p. Well, I know the value of h. H is 7, yes? So we're saying that 7 plus the value of p is equal to 14. So what I need to do to solve it, I need to subtract 7 from both sides, and I get p is equal to 7. Plug in our three values. X is equal to 1 over 4 times 7 times y minus, so k is 3 squared plus 7. Now there's only one real thing that we need to simplify. We need to simplify the 4 times 7, which is 28. And we have y minus 3 squared plus 7. And that's our equation. That's it. Any questions on this here? We good with this here? Do we need to see another example using this, the vertex in focus or directrix in focus? Yes? Okay. Let's see if they have one given us vertex in focus. Yep, no. So we can do this here. Vertex is always h comma k. And here, the k value stayed the same. The second value for the focus stayed the same as the vertex, yes? It didn't change. But the x one did, so it would be h plus p. If the k, or the y value change from the focus and the vertex was different, then I would use k plus p. Because I'm just matching it up to the general equation. So our general equation for this here is x is equal to 1 over 4p times y minus k squared plus h. Since that's the value that changed. Now the value of h is 4. The value of k is 1. And we're saying 6 is equal to h plus p, yes? 6 is equal to h plus p, because that's where it lines up for this here. Well, I know the value of h. The value of h is 4 plus p. So what do we need to do? I need to subtract 4 from both sides. I need to get p by itself. 6 minus 4 is 2. 6 minus 4 is 2. And then what can we do? We can plug p, h, and k back in. Because I found h and k from the vertex. And I use the fact that the focus has p in it. So for this one here, it's h plus p. For the other type that we could have, it's k plus p. Set it equal to it and solved it. So we have x is equal to 1 over 4 times 2 times y minus 1 squared plus 4. Well, 1 times 4 is 8 times y minus 1 squared plus 4. And that's it. That's our equation. Any questions on this here? What is this here? 4 what? 4? This here is? What changed? The 4 became a 6. So looking at this here, I have HK, yes? The focus is what? H, K plus P. So with this, the K value wouldn't stay the same because I'm adding something to it, yes? So if that was the case, I'd be using this. Here, I have HK. What happens to the H value? I add something to it, yes? So it changes. So if the X value is changing from the vertex to the focus, we use this. If the K value is changing, the second value is changing, we use this one. So it tells us which equation to use. And then once we have that, then we use all the properties of it. Those differ. The focus is H comma K plus P or H plus P comma K. We use those properties there. Does that make more sense now?
Yeah.
And it's revolving around those formulas. Which one does it match up to? That's what we're going to use. Now the other type is this here. We have two main equations. Y equals, we have vertex form. So this here, because it gave me the vertex, we're going to be using vertex form, which is this. Y equals A times X minus H comma K. And I want to find the equation. Now they gave me the vertex already, which is my H and K, yes? Vertex is H and K. So we can plug those in because I'm wanting to find the general equation. So if I plug the vertex in, negative 6 comma negative 12, I get Y equals A parentheses X minus negative 6, close parentheses squared, minus 12. But I don't normally leave a negative minus a negative because that's the same as plus 6 for this here. Because a negative and a negative make a positive. And we have this here. Now, to find the value of A, we have to plug this point in, 0 to negative 24. And I don't plug it in for A, I plug it in for X and Y. So it's saying the value of Y is negative 24, and the value of X is 0. And we do this because now I just have A. A is the only variable that I have in there. So plugging that point in lets me solve for A. So I plug the vertex in first, then I plug in the point. Now I solve for A. We can do 0 plus 6, and 0 plus 6 is 6. And then we can do 6 squared, and 6 squared is 36. So we got down to this here. Now we still need to get A by itself, so the first thing I do in getting A by itself is to add 12 to both sides, and we add 12 to both sides. I get negative 12 equals 36A. From here, I'm going to divide both sides by, not negative 12. We're going to divide both sides by 36 because I want to get A by itself. I want to get the value of A by itself. 36 divided by 36 simplifies to 1. And if you type it in the calculator, negative 12 over 36, it will tell you it's negative 1/3. It'll tell you it's negative 1/3 because 12 over 36, negative 12 over 36 will simplify to 1/3. And what we can do next is now that we have the value of A, we can plug it back in. So where we had Y equals A times X plus 6 squared minus 12, I can plug in negative 1/3 in for A. So we'd have negative 1/3 times X plus 6 squared minus 12. And that would be our answer. So we did that whole process of plugging in that point X, Y to find the value of A. And once we found the value of A, we plugged it back in. We plugged it back into the function. Questions on this here? Questions on this here? I need to pause for a second so y'all can finish. Okay. Just let me know when y'all are done. Okay. Now we have another formula to do this with, and that's with x-intercepts. When we're given the intercept form, this here, when we're given the two x-intercepts. And if I'm told we're using the intercepts, we're using a different equation. X minus p times x minus q. Because the two intercepts are p and q. The two intercepts are p and q. So negative 16 and negative 2. So what I'm going to do is I'm going to plug those in. So x minus negative 16 times x minus negative 2. Well, negative and negative make a positive. Negative and negative make a positive. Now from here, what we're going to do is we're going to plug that point in. So y is going to be 72. X is going to be negative 18. So we're negative 18 plus 16 times negative 18 plus 2. And we get this here because, again, now we have an equation where a is the only variable. If you're having trouble keeping up at this point, just watch, go back to the video, and copy it down. Because I'm not going to have time to slow down a little bit. I'm sorry. Now, at this point here, you could type this whole thing into the calculator. You can do parentheses negative 18 plus 16, close parentheses, open parentheses, negative 18 plus 2. You can type that whole thing in. Or if we do it by hand, it would be negative 2 times negative 16. Now, negative 2 times negative 16 is going to give us 32a. And lastly, we're going to divide both sides by 32. Now, it works out to be 9/4, I believe. Which we would, again, at this point, plug this into the equation to get this here. So we plugged x and y into it to solve, to get a by itself. And once we found the value of a, we plugged it back in. Does this make sense? Yes? Yes? Unfortunately, I'm sorry if you weren't able to get that down, because what I realized is I need something back here to start. Hold on, where's it at? Here it is. These here, I skipped 6 through 10 on accident. That's why my thing wasn't working. I didn't realize I'd missed that. Okay? So the bell's going to ring here shortly. Let me finish 2 examples before y'all head out, okay? Now, the first type is this here. 2 parentheses x minus 2 squared plus 5. Yes? We call this vertex form. And the reason it's vertex form is, well, it gives me the value of h and k, yes? And the vertex is what? H comma k. So what is the value of h for this here? Inside the parentheses, it's negative 2, so it comes out as 2, positive 2. And k would be 5. Axis of symmetry is x is equal to h. H here is 2. We're done. That's it. So here, because it really told me what the vertex was, straight from the equation, negative or 2 on the inside is h. Since it has minus 2 inside, it comes out as positive. Plus 5, we have 2, 5. Axis of symmetry is x is equal to h. H is still 2, so x equals 2. Questions on vertex form? Standard form, this one here. The vertex is negative b over 2a. So the first value is negative b over 2a. So to get that, well, the value of b, a is 1, b is 2, and c is negative 1. We'll not ever put variables x into for a and b. It's just the number in front of them. So here we're going to have negative 2 over 2 times 1. Well, that'd be negative 2 over 2, which is negative 1. So the x value of the vertex is negative 1, yes? Because negative b over 2a, when we plugged in the values, we got negative 1. Would y'all agree with that there? Yes? Now, the axis of symmetry is x equals negative b over 2a. Well, we already found that. It's negative 1, yes? So the x value of the vertex for these here and the x value of the axis of symmetry will be the same. X equals negative 1. X value of the vertex is negative 1. These two will be the same. Now, to find the y value, you have to plug that value back in to the function. So this function is x squared, so we'd have negative 1 squared, plus 2 times x, so 2 times negative 1, minus 1. I plug that value back into the function. And at this point here, you could simplify this or do this in the calculator, but negative 1 squared would be 1, minus 2 minus 1, which simplifies to negative 2. And that's what we get for this here. That would be our answer for this one here. So we have to use that equation, negative b over 2a, comma f of negative b over 2a, to get the vertex for standard form. And the axis of symmetry would be x is equal to negative b over 2a. Any questions on any of this here? Are we good with this here? Yes. Go this way. If anybody, everybody get this one written all the way down? Yes? Okay. Awesome. Your test is tomorrow. Your test is tomorrow over this stuff here. The 2 paper worksheets, I will give you till Monday morning, okay? Stop by my classroom before the end of first hour Monday morning to drop those off. I'll give you to the first thing Monday. Big Idea Math is due at the end of the day Friday, midnight on Friday. I'll remind you guys tomorrow, but have a great rest of your day. Stormy? Yeah. You might need those. But I need to stop.